This is an explanation on how to write linear equations in standard form, which is ax plus by equals c. That x and y will always be there, and that a, b, and c will be numbers. Before we actually jump into writing equations in standard form, we need to talk about equivalent equations. There are infinite ways of writing the same equation in standard form, and we can change the way it looks. So in our first example, we have 2x minus 6y equals 4. To write one equivalent equation, I'm just going to choose a number. I'm going to say 2, so let's multiply each side by 2. That means we need to multiply everything there by 2. So the left side by 2, both terms, and that right side by 2. And when we do that, we get 4x minus 12y equals 8. We could also look at this and say, they're all even. Let's multiply everything by a half. Okay, really, we're going to divide everything by 2. And when we do that, our 2x would become x, our minus 6y would become minus 3y, and our 4 would become 2. I could have even just multiplied everything by negative 1 instead and changed the signs of everything, and we'd have negative 2x plus 6y equals negative 4. So just because your eventual standard form equations might not match an answer I give you doesn't necessarily mean that they're wrong. Okay, if you have a doubt, you can always make sure you ask me going forward. Let's look at example 2, actually writing an equation. In this case, we're writing an equation from a graph. Now to review, we've done slope-intercept form already, where we had y equals mx plus b. And we said that the m was the slope and the b was the y-intercept. And we had point-slope form, which was y minus y1 equals m times x minus x1, where the m was the slope, and that x1, y1 was from an ordered pair. Now the issue with standard form is that a, b, and c, those other numbers in the equation, mean absolutely nothing right now. Okay, it doesn't give us any information like slope-intercept form does or point-slope form. So we can't just take the numbers in a problem and just stick an equation in standard form. It doesn't work like that. We need to choose to write it in one of the other forms first. So even though we're going to be writing it in standard form as our final answer, we need to choose to start with either point-slope or choose to start with slope-intercept. Either one will work. I tend to look at the example and say what information am I given and maybe which one might be a little bit easier to choose, okay, but it really doesn't matter. So in this here, we have a graph. Okay, my graph does not happen to go through the y-axis, so I don't know the y-intercept. So I'm looking at this and say I can figure out a slope. I have some points. In this case, I'm going to choose to do point-slope form. If we calculate the slope, slope goes down 3, 1 right. So our m would be negative 3 over 1, or just negative 3. And now I'm going to choose a point. I'm going to use this one here, and I'm going to write my equation in point-slope form first. So that would be y minus 1 equals negative 3 times x minus 1. And now I can distribute and rearrange things and get this equation in standard form instead. So I'm going to distribute. So I have y minus 1 equals negative 3x plus 3. I need to add my 1 to this side. And that actually happens to put it into slope-intercept form. I'm going to add my 3x to move it to the left side. And I end up with 3x plus y equals 4. My x's and y's are on the same side, and that is my final answer. Moving on to example 3. Writing an equation from 2 points. Once again, we can't automatically put it into standard form, so we need to choose either point-slope or slope-intercept first. Okay, I have 2 ordered pairs. I need the slope first. So I'm going to do m equals negative 1 minus negative 3 over 3 minus 2. That becomes a plus So it really ends up being 2 over 1, which equals 2. Once again, I have my slope. I don't know my y-intercept. Neither of this have the 0 there. I prefer to use point slope form. Okay, I'm going to choose that first ordered pair. So I'm going to say y minus a negative becomes y plus 1 equals 2 times x minus 3. And now I can distribute and move things around. So we have y plus 1 equals 2x minus 6. I'm going to subtract 1 from both sides, so y equals 2x minus 7. And then subtract 2x from both sides, and we get negative 2x plus y equals negative 7. And example 4. This is a little bit different than the other ones. Here we're kind of given a general format of an equation already in standard form, and we're trying to figure out a missing variable. Okay, so here we're trying to figure out what is the value of a in this line that goes through negative 1, 0, and kind of looks like ax plus 3y equals 2. Okay, and normally we don't have that a there. Normally that is a number. That's what we're trying to figure out. In order to do that, we need to fill in some other information. In order to figure out that a, we would need to plug in an x and a y in this case, and we get that from that ordered pair right there. So I'm going to plug things in. So it'll be a times negative 1 plus 3 times 0 equals 2. And if I continue solving, this would really be like negative a. That'd be plus 0 equals 2. So I don't really need that. And if negative a equals 2, that means that positive a must equal negative 2. And our final answer, if it says to complete the equation, we found a. Now I can plug that in and say that my actual equation would be negative 2x plus 3y equals 2. So as you continue on to practice putting things into standard form, reminder, you can't automatically jump into standard form. You need to choose to do point slope form or slope intercept form first and then move things around.